morning, students. This morning we'll be looking at transformation geometry with subtopic describing a transformation using base vectors. Now for the learning objectives, at the end of the lesson, students should be able to apply base vectors to describe a transformation and also to determine the image using base vector. Now let me just start with base. Now, what's a base vector? A base vector is a matrix in the form of this, whereby you can write this as 1, 0, and 0, 1. Your 1, 0 represents your I component, and your 0, 1 represents your J component. Now, I component, that's along the x-axis, and your J component along the y-axis. So that's what we're going to be using. Now, for this, the base vectors can only be used to describe the following transformations: reflection, rotation, and enlargement, as you'll see in the course of the lesson. Now, for the first example we want to consider, they use base vectors to describe the transformation represented by each matrix. We have this matrix 0, 1, 1, 0, B, minus 1, 0, 0, and minus 1. Now, for question A, we are going to start. Let me have this. And that's our. Now, we are going to use the base vectors as I showed you in the first slide. Let's call this I, and this is J. That is, this point is 0, 1. Sorry, 1, 0. This is 1, 0, and this point is 0, 1, using base vectors. Now, we are going to draw the image of this. This is telling us that when x is 0, y is, that's the image we want to get now. 0, 1. This is 0, 1. So we have this point 0, 1. Now my 0, 1 represents the image of I. That is I prime. And my 1, 0, that is x is 1, y is 0. This same point. So this is J prime. The first object here represents the image of x, and this represents the image of y, which is still J. So when you look at this now, there is a flip. If you look at this, the J is now at the x-axis, while the I is on the y-axis. You see that there is a flip there. So that means that we have a line going this way. That's the mirror line. If you look at this now, this, my I has moved up here, and my J coming down to this place. Now you see that there is a flip between the 2 points. So this is the mirror line. So the matrix this 0, 1, 1, 0 represents reflection. Now, if it is reflection, you must state the mirror line. Now, this mirror line is y equal to, now reflection, and the mirror line is y equal to x. That's what you have to do for question 1. Now, for the big question, we have minus same thing. You have your base. We have I, and we have J. We want to find the image. Now, minus 1, 0. Minus 1, 0. This is I prime. That's the image. And we also have 0, 1. 0, 1. We have 0, 1. This will be J prime. Minus 1, 0 is the image of I. Y 0, 1 is the image of J. Now, if you look at this, my J is fixed. The J is fixed. It's only the I that is what? That is changing. That means that there is a reflection along the. Now, at this point now, we have what? A reflection on this axis. We are flipping. We only flipped I to this place. So, the matrix minus 1, 0, 0, 1 represents reflection. Now, if it is reflection, what's the mirror line? The mirror line is x is equal to 0. So that's how to use base vectors to get the image of transformations. So now for this other one, let me just take one question so we end for this. Now using still the same base vectors, I have J and I have I. I've said I've done reflection for. Let's just take this question on enlargement. Center OO, scale factor 3. Now, if this is center, that's center OO. Scale factor 3 simply means that you multiply this by 3. That means that we're going to have an extension. Let's call this 3i. Here also we're going to have an extension 3j prime. This is I prime. Now said, use base vector to write down the matrix which represent each of the following. Now, what's the new image for I? The new image of I is 3, 0. The new image of J is 0, 3. So this will give us this, or you factor out this. So that represents enlargement. So with this, we'll come to the end of the lesson. So we're going to have more examples in the Google Classroom. So there you can ask your questions and you'll be responded to. Thank you and have a wonderful day.